B of Module 6, Division Method for Hash Functions. The knowledge part, just for your optional reading, okay? But the main part, I think most of you are interested, is the final review part. In this part, I want to do just 2 videos. The first one, the final review part. The second part, the new knowledge part. B.1 Selected Questions from Quiz 5. Yeah. Some students send me emails asking me to give answers. I think the reason very simple, because there are several questions in the final are closely related these questions, quiz 5 questions. So in this video, I want to discuss those questions in detail. Because although you have the correct answers, but how to find those answers? Still, for some of the questions, it may not be that easy. So I want to go through all the details, discuss those related questions. All right, so let's start. The first question, question 2. It is a simple question, but this question related to 2 questions in the final. Question number 3 and the question number 18 in the final. Okay, FQ3, FQ18. Yeah. Here I just want to explain the background clearly. Yeah. The reason is very simple. I hope after you watch this video, you won't miss these 2 questions. Okay? Yeah. Pretty easy. Yeah. You can get A points from those 2 questions easily. Now, when a heap with R the number of nodes, which following statement is correct? So we compare the number of internal nodes and the number of leaves. Greater, less, equal. So we compare those 2 numbers. Okay. Here the answer is very straightforward if we understand the basic structure of a heap. Yeah. We know there are only 2 cases for a typical heap. Yeah. Here I just draw 2 examples. One case, yeah. So I like to draw this way. Yeah. All right. Then this one, okay? Yeah. The last node only has left child, but no right child. Okay? That's the first case. Second, yeah. Quite similar. Yeah. The only difference is the last node. So you can see, these 2 examples represent typical structures of a heap. Yeah. All right. The left-hand side one, you can see the number of total nodes even, right? Even. The right-hand side one, the number of total nodes odd. Okay, yeah. So this question, so we are talking about are the number of nodes, right? Yeah. Now you go back to our final, these 2 questions. The first one, FQ3, odd case. FQ18, even case. Okay, so you can see, quite basic here. Yeah. For the even case, so now you can see, yeah, the number of leaves, these are the leaves. Okay, yeah. Then the remaining internal nodes, right? So here you can see for the even case, this is true. The number of internal non-leaf nodes equals the number of leaves. Okay, so this equation always true. Okay, this This equation always true for the even case. All right. For the odd case, yeah, let's look at the odd case, the equation. Yeah. Slightly different. Yeah. All right. Number of leaves equals number of internal plus 1. Okay? The difference is only 1, exactly 1. Always like that. Okay? So these are the two typical cases for a heap. Yeah. Based on this background, then you can answer these questions in a straightforward way. Okay? For example, equals odd, right? Odd not equal, but which one larger, right? Which one is larger? Yeah, leaves larger. So, this is correct. Okay? All right. Yeah, hope you use this background, you can answer those two questions easily. Okay? Don't miss that 8 points. Pretty big, 8 points. Pretty big. Okay? All right, yeah, so that's the first question. Second question. Question number 5. This one, targeting final question number 21. Yeah. All right. Given a heap with 42 nodes. So in the final, we replace this 42 number, right? 77, right? Yeah. So if you understand the method, so whatever that number is, you apply the same method, you can solve the problem easily. Okay. How many leaves are there who have the longest path from the root? Yeah. That's the meaning. First, you should understand the question well first. Yeah. So let me draw a heap. Yeah. So let me draw here. Okay. Yeah. Start from root. Okay. Yeah. Yeah. So let me still use the similar diagram I draw in the previous example. Even odd here not important. Okay. Yeah, even odd number not that important. Yeah. Based on our method, we use the same method. Okay, all right. But now let us examine all the leaves. Yeah. Two parts, the leaves, this part and another part. Only these two parts. These two parts, their main difference is the longest path from root, different. The longest path from root, 3. You count the number. How many edges? 1, 2, 3. 3. Okay? Yeah. If you count here, the number of edges, 1, 2, 2. That means we need to take this group, not that group, not that 2 group. We take that 3 group. Yeah. All right. With this understanding, now we do the calculation. Okay. We do the calculation for the general n number. Yeah. So this n number, general n number. Okay. How do we know? How do we calculate the number here? Okay, this part. So you look at the structure of this heap. Okay, yeah. All levels are full except the last level. Okay, so this last level, it's not full. Okay, or in general, it may not be full. In general, yeah. Only a very special case it is full. Okay, yeah. In general, not full. Yeah. So we want to calculate the number of nodes at the bottom level. Okay, yeah, bottom level. Yeah. So that's easy. Yeah, with that understanding, observation. Okay, first find the largest number. So this way, pretty similar to one way we did before. So remember, binary tree, right? The binary search. Yeah. So this question, the method is close to, the way we did the worst case binary search, right? So think about that. So how many nodes, how many elements in binary search correspond to the worst case, right? So very close to that. Yeah. All right. Yeah. Here we do this. First, find the largest k such that 2 to the k minus 1 less than or equal to how about this? Less than, right? Yeah. Because equal to, then we take difference, that's 0, right? Nothing is there. Yeah. So let's find less than. Then when we take the difference, we always have a positive number. Okay? All right. Less than n. Okay? That's the first step. Do this. Here, our n equals 42. So do this. Minus 1 less than 42. Oh, sorry, not 6. 42. Yeah. Very easy when k equals 5, right? When k equals 5, 2 to the 5th minus 1 less than 42. This number 31, right? Yeah. So that means above the bottom level, there are 31 nodes. 31 nodes. Now we want to calculate the number of nodes at the bottom level. So we need to do subtraction. Yeah. So the answer is 42 minus 31 equals 11. We do that subtraction. Okay? So this method, very general. Yeah. When you have a different number, 42, you change to another different number. Yeah. Let me change to 100, for example. Okay? N equals 100. So that's easy. What is number 2 to the k minus 1 less than 100? Okay? So you can see 2 to the 6th, right? 6th. Yeah. 64 minus 1, 63. Yeah. So this number, this time, 63. Yeah. Then the answer, you do subtraction. 100 minus 63, you get what? 30. Yeah, 37, not 27. 37. Yeah. So that's the way you solve this problem. Question number 21 in the final. Okay. All right, so that's our question number 2. Question number 3, this one. Yeah. This is another relatively hard question. Yeah. For the quiz, the answer is 3, right? Yeah. But you may not know, or some of you may not know how to get this number. Here, I give a small number of elements, so it is relatively easier to find the answer. But in our final, so this question, I increase the element by 1. So you will get 1, 2, 3, 4, 5. Yeah. So you will have a little more cases. Yeah. But here I give you the analysis procedure. Yeah. So to get the correct answer, I hope you can apply this procedure on this question to find the answer. Yeah. Here, so let me use this simple example to do the analysis. Yeah. All right. These 4 elements, and we want to build a max heap. So you know the max heap, the property of the max heap. Yeah. So when we do the analysis, we try to use special elements to help us to make different cases. Then we look at each case. Yeah. How many different heaps in each case? Then we will count them, adding together. Yeah. So that's the basic procedure. First, so what are the special elements in this heap? Very easy. The one with the maximum value 4 here, and the one with the minimum value, these two, very special. Yeah. So they play a very important role in our characterization. First, the largest element for the max heap, it must be at top, right? Yeah. So that's the easiest one. So we put 4 at the root, right? Then remaining, there are only 3 nodes like that. All right. Okay. Then we need to consider the node with minimum value. With first question, which node this minimum element cannot be there? Which one? We cannot put this minimum element. Okay. So you can see this node, you cannot, because it has a left child. Based on the max heap property, how can you put the minimum element there? Because its value supposed to be greater than that of its left child. So the minimum cannot be greater than any other value, right? Yeah. So here you reduce the cases. Here you only have 2 cases, right? One is you put the minimum element here. Another is this one. So let me draw another diagram, but this time I put 1 there. Okay? Yeah. All right. Only these 2 cases, right? Yeah. Then the remaining 2 values, 2 and 3. Okay? 2 and 3, right? So let's look at the possibility. Yeah. Can we put 2 here, 3 there? If we check the max heap property, no violation, right? 2, 3, no violation. Okay. Yeah. Can we put 3 here, 2 there, right? Another way, no violation, right? Yeah. Then both okay. So we have 2 possibilities. Yeah. So we put the 2 there. All right. Then so look at the remaining 2 nodes here, 2 and 3. In order to avoid a violation, we can only put 3 here and a 2 there. Okay? No other possibility. So you can see the number of cases, just 1. Yeah. So the final answer, 2 plus 1, 3. Okay? All right. So that's the way we make the analysis. Yeah. Now you have 5 elements, so you look at the maximum element, minimum element, right? So maximum, you can fix it easily on top, the root. Yeah. Minimum, the possibility, right? So which element you can place that minimum value, which node, okay? Then you use those cases as the case 1, case 2, case 3, okay? For each case, now you look at the remaining elements, okay? Using the max heap property, try different ways to arrange remaining 3 elements based on the max heap property, okay? So for each case, you can get a number, okay? 1, 2, 3, some number, okay? So you do that for each case, and at the end, add those possible numbers together. So you get a final answer, right? All right. So that's the question 6, targeting final exam question, the last one, number 25. Right? All right. the last question of this video, targeting question final number 24. Yeah. All right, so here, let us go through the whole procedure. The max heap with 500 nodes, yeah. Position number from 1 through 500. Okay, yeah. And now we want to look at the particular node with this given position number. Okay, yeah. What is the height of the node? This node, yeah. Height of the node. Yeah. We have the formula counting the number of nodes with a given height, right? But here we need to use information a little more than that formula. A little more than that formula. Yeah, because we need to know what the nodes with what position numbers that correspond to certain height number. Here we need that part. Okay. All right, so here let me draw a diagram in this way. Let me draw a straight line. The position number from 1, the last one 500. N, right? Yeah, 500 is our number of nodes, N. Yeah. Then, first, let's look at the leaf. Position numbers for the leaves. We have that formula, right? So if you look at our nodes, we have that formula for the leaves, right? Yeah. Position numbers, yeah. What's that? Yeah. N over 2 floor function plus 1 through N. Okay? Yeah. This corresponds to leaves. This block, okay, corresponds to leaves. Okay, leaves means the height equals 0. Right? Height number equals 0. All right. Then let's look at the next block. Height 1 block. Okay, yeah, we have a height 1 block. Yeah, let me use this part. Yeah. Height 1 block. Here, moving forward over 4, right? Plus 1. And here the end position number N over 2. Okay, so this block corresponds to the nodes with height equals 1. So how about that? Okay, how about that? Yeah, the second block. Okay, yeah. All right, second block. Yeah. So, all right, yeah. Next block, you can see. Yeah, let's go to another block. Okay. All right, so here, N over 8 plus 1, and here, N over 4. Right, so next block. This part, this block corresponds to height equals 2, and so on. Okay, so you can use this structure. Yeah, this structure you can do partition on all the position numbers from 1 through 500. Partition. Okay, so it's a partition. Okay, perfect partition. Okay, yeah. After that, based on this understanding, now let us try to calculate. Okay, so this position number falls to which block? Which block? Okay, fall to which block? Yeah. All right. Yeah. So we can do some calculation. Right? Yeah. All right. So here we can try a little bit. Yeah. First, 500 over 2 floor function. Okay, floor function 250. Right? Yeah. Second, 500 over 4, 125. Right? Yeah. Okay. Yeah. Greater than 123. Yeah. Yeah. Covers that. Okay. So look at this. Look at this. Look at this block. How about this? Yeah. Let's do another calculation. Okay, 500 over 8. What's that number? Okay, 6, 2, right? Yeah, floor function. So 62. Okay, all right. Now we can get to this part. Okay, yeah. 62 plus 1, right? 30. 62, 63 through 125. So position number 123 falls into this block. Okay, corresponds to height 2. So we get the answer. So we get that answer. Okay, yeah. Now you use this method. So this partition method. So this understanding. So now in our final question number 24, we have a different number. So that's 620, right? Yeah, different number. This number also different. Okay, yeah. So you have those two numbers, but you try to calculate these numbers and see which block covers the given number. Okay, you can get certain, some specific block that covers this given number. Then you can figure out the height for that block, right? You can easily see the height for that block. So you can get that answer. All right, so that's the last question of this video. Yeah. In my next video, so I will give you hints for several questions in the final. Yeah. So I just look at, currently I have covered several questions, but other than the questions I have covered, I look at the remaining questions. I just select a few more questions in the final exam. Relatively hard, those questions relatively hard. So then I will explain a little bit, hints a little bit. Then you just do it by yourselves. All right, so let's stop here.